John here. Sorry about the noise in the background. I've got the Cormac working on another part, and it's got another hour and a half of runtime, so I need something else to do. Here is a 1 horsepower electric motor. For making knives, it's very, very handy to have a disc sander, so that like here's a blade that I got water jet. The surface looks kind of pitted and crappy and nasty and stuff. It takes a lot of hand sanding to get that flat and smooth, whereas a disc sander can be done in seconds. Same thing for all these titanium handles. See, there's text on there, there's lots of big scratches, lots of stuff. So to finish them nicely, zap them on a disc sander, and they get not only flat, but nice and smooth. And then you can buff them with the Scotch-Brite wheel. Yeah, I tried to buff this handle just with the Scotch-Brite wheel, but you can see the vertical lines are still there. It would take a lot of effort. So I need a disc sander. Now, talking with my my mentor knife makers, Brian Ty, he's got a disc sander he made himself. My buddy Brad Southern, thanks for all the advice, buddy. He's got a disc sander he made himself, so it's time for me to make a disc sander myself. So I've been chatting back and forth with Brad about what to get. He suggested talk to the local electric motor repair companies, and they might have something that they've had on the shelf for a long time, that they've rebuilt and haven't sold yet or whatever. So I called around to all the places around here, and hardly any of them had motors this small, 1 horsepower. They deal with like 50 horsepower units. So unfortunately I couldn't find anything local that was, you know, cheap. So then I came across this website, Automation Directs. I've known about these guys for a few years now, but I've never seriously looked at their inventory and been in the place to buy some of their equipment. But I could not be happier with the transaction that I did. I bought this motor. It's a 1 horsepower, 230 volts, 3-phase motor, and a 1 horsepower VFD. This is a variable frequency drive. Total cost was, I'm forgetting the numbers, but I think the motor was 120 and the VFD was about 180. So the VFD is actually more expensive than the motor, and free shipping anywhere in North America. It came in like 4 days, including a weekend, to Canada. Couldn't be happier. No brokerage. They take care of all of that. I had to pay duty and tax when I checked out, but that's okay. It was just tax. Everybody has to pay tax. But yeah, so I got a 1 horsepower motor, which should be plenty ballsy enough for a disc sander. Brad's is 3/4 horsepower, Brian's is 1 horsepower, so it's the right range. So to make a disc sander, you need several things. Of course, you need a motor. You want to be able to vary the speed, and everybody says they like a lower RPM for a disc sanding, because you don't want to burn up the titanium or kill the sandpaper or whatever. So you want to be able to turn down the speed and find the sweet spot for your own purpose. So you need a VFD. You could also use a DC motor with some sort of DC motor controller, but I think these are more abundant and easier to find. And I believe using a higher voltage 3-phase motor, you actually get more torque out of it. So the cool thing about a VFD is that this takes 120 volts in right from the wall and spits out 230 volts 3-phase. So from single phase low voltage to 3-phase high voltage. Very cool stuff. So you get more horsepower and power and torque from a motor. And as far as the cost of the motor, they were about the same for the 3-phase as they were for the single phase, so that was an obvious choice. The VFD comes with this incredibly thick instruction manual. I'm sort of worried to read this, but it's all there. Okay, so the next thing you need is a disc. This is a disc sander, of course, so you want a disc on it. I highly recommend that you just go out and buy one from, what are they called? crap. I'm gonna put the link right there. It's something like Beaumont Machine Works. Link right here. They have one. They're the guys who make KMG grinders. They have one for about $89 or so, and it's exactly what you need. So I highly recommend you get that. I, however, for one, don't have the time to order one, wait for it, have it come in, and I need one like now. So I'm going to make one. To do that, this is a chunk of 2-inch round aluminum, and this is a 10-inch by 10-inch plate of 1/4-inch aluminum. 1/4-inch aluminum. And the basic premise is that. Okay, if you can put your creative hat on, I'm going to drill and tap 3 holes into the hub here, and it's basically going to sandwich onto the plate like that. Does that make sense? And then on my Tormac, I'm going to mill this into a circle and mill the bolt pattern for these. And then I'm going to also drill and tap the bolt pattern for these, so that I have a rough circle, and then I can put it on my lathe and true it up and hopefully balance it fairly well. And this is a 5/8 inch shaft, so I got a 5/8 drill bit here. Just going to punch it through. But first step for today is to do this. My mill is obviously busy right now, but my lathe is not. And now that I have enough power in the garage, I can run both machines at the same time, which is pretty wicked. Again, sorry for the loud noise. I don't know if it's a lot of background or not, but it's pretty loud in here. I just feel like being productive while I'm being productive. Alright, here we have this 2-inch piece. I have faced off each side with a really crappy surface finish. Sorry about that. I've center drilled the hole using a center drill. I find this lathe could use a bit more horsepower. So to drill to a bigger size, I find that I have to step up in drill bits. These are all parabolic flute drill bits, which is great for deep holes in aluminum. 1/4-inch, 3 or 5/8, 5/16, 1/2 inch, and then the 5/8 is over on the other side. So I'm just going to step these up and bore this thing out. Now, although this is a CNC machine, I'm going to be basically manually drilling it. Hit the S button on the keyboard to turn the spindle on, and then just crank, crank, crank. You get the feed rate just right, then the chips are even and smooth, and that thing's long. I'm telling you, for aluminum, these parabolic drill bits are wicked. Now, I'm a little concerned that this fairly cheap quality drill bit is not going to make a very nice hole to go onto that shaft. Ideally, I would want to bore it or ream it or something, but I'm sure this is going to make a hole that's too big. So we'll see how sloppy it is. I don't know yet. When in doubt, I have lots of these aluminum bits, so I can make a lot more of them if I need to. Alright, 1200 RPM was a little high for this big drill bit. I had to really crank that thing. But it worked. Luckily with aluminum, it's not so sharp that it's really going to tear up your hands. It's kind of pokey, but it's not that sharp. If this were steel, I wouldn't do this with bare hands. There we have it. Let's go try it out. Not bad. You know, I'd say that is perfectly acceptable. It's got the tiniest bit of wiggle to it, which which is understandable. It's a big drill bit, but that's much better than I was expecting. So I'm making a bit of progress on my disc sander project. Trying to squeeze it in before Blade Show and for this first run of knives to have it all ready. So remember how I said I'm going to use a big sheet of 1/4 inch sheet metal, aluminum. This is actually what they call sheet metal and not plate, but it should work. It should be flat enough. So I was lucky enough, this is my Norseman handles fixture. I was lucky enough that I could make 4 bolt holes line up around the outside of the circle so that I can cut it out. And you can see I got those drilled. I got these drilled and countersunk. I'm going to use these guys. They go in there nicely. And then next I'm going to use a right here, wicked awesome aluminum. It's called a streaker end mill from Imco. Love this thing. Just eats up aluminum. So I'm going to use that to basically cut around the circle. Now, if you're savvy, you'll notice it's being bolted on from the outside of the circle. When I cut around the inside, it's going to fall out. So what I'm going to do is not cut all the way down. I'm going to cut 200 thou down, leaving 50 thousandths of an inch of a lip, and then I'm going to cut a slice here all the way down, and a slice here, and a slice here, and a slice here, basically leaving 4 little tabs, 50 thousandths thick, that I can break off, sand off, whatever. So let's do that right now. Oh, another tip, buy the one from Beaumont Metalworks. This is too much work. For 80 bucks or whatever they want for it, yeah, it's worth the time savings. That's one of those do what I say, not what I do tips. Now usually I could feed this end mill at about 40 inches per minute, but just because of rigidity issues, the way it's bolted down, and because I don't want to have any problems, I cut it down to 20 inches per minute. Like butter. That was awesomely uneventful. And since the first one worked, I have faith that the second one will work. Cool beans, man. That worked incredibly well. You can see a tab right there, and there. You can't see it so well, and over there. I love that streaker end mill because, as Eric likes to say, it makes these little toenail chips. Got my terms mixed up there. But yeah, nice long chips, fairly thick. It's another thing while machining that I've really picked up in the past 6 months, no, probably a year, is having an air hose, having the compressor on all the time, always pumped up. It's extraordinarily helpful for milling. Not only does this machine require it because the power drawbar, but just for blowing the work off, for cleaning the table off, for blowing out holes, for everything. I use it all the time. These are going to take some effort to pop out. BRB. Yo. Ta-da! Boom, boom, boom. Not a not bad wall finish. So you can see here I threw a vise on the machine and I've got my hub right there into the multi-jaw vise jaw thingies. And this is where I'm going to drill and tap my 3-hole pattern into the top. So first thing I have to do is find the center of that hole. And in order to do that, use my handy dandy Tool 99. Tormax Digital Touch Probe. Love this thing. So I've got my jog pendant. I'm going to go X. Because I need to re-aim you. Z down. Y forward. Oh, limit switch. Okay. X over a bit. Z down. Okay, now right now you can see it's not very centered in the hole. That's totally okay. It may look like it to you, but like you can have it way off to one side, doesn't matter, as long as it's in the hole. Okay, and then you go to the probing screen and you hit find center. First they like you to test the probe. Yeah, the little light comes on the screen, so that works. That way you don't ruin it. So it finds the side to side, finds the front to back. For some reason likes to do the side to side again. That's 0. How cool is that? For those of you who know anything about work offsets and coordinate systems, all my palettes have their own different coordinate system, and I just created a new one for this one. So this is G58. G54 is kind of the default one, everything uses it, but from now on this vise is going to be G58. That way I can put my palettes back on and everything is the way I need it to be at G54 or whatever they happen to be. Anyway, that's boring. So now I just have to put the right tool in, zero it on the surface. I still have to write a code to drill the 3 holes, and I'll probably use the tapping head to tap the holes too. Now I've got my first tool in the tool holder. It's a center drill, or spot drill basically, and I'm going to touch it off to the surface of the work. So see, I've got a 2000 shim here, and I'm just going to use the controller and just go down. There. Now it doesn't move. Now I know the tool is 2/1000 of an inch above. Here we go. So this is a .265 drill bit, which is a perfect tap hole for M8. So I got to tap these 3 holes to a metric M8 thread. Don't ask me why, but I measure everything in inches, but I use metric fasteners. It's just the way it is. I could be fancy and use the tapping head, just actually use the machine to tap the hole, but for just 3 holes you got to write a program, you got to take it out and put it together and all that. For just 3 holes, I think it's faster just to hand tap them. Back off every few turns. I'm not that picky. Helps to keep the tap lubricated. I should get some WD-40 and spray it in there. I can feel it getting sticky, especially in aluminum. It gets some gummy. But yeah, so just gonna tap those and then keep going. If I had more time and was fancy, I would have turned the face of this, the OD of this off. Make it look pretty, but it really doesn't matter. Another thing I was considering is to turn like a hump, a step onto this, and then mill a hole but there isn't much room. But anyway, mill a hole here so that these two kind of slide together and the disc doesn't move that way. Because currently, not that it really matters for this part, but the bolts are taking all the force in shear. When this is trying to rotate against the hub, the bolts are what's causing it to stop. But if the hub was actually hubbed onto the disc, then at least the two won't move that way. And the bolts are still keeping it from shear from rotating, but at least it won't fly off. But it doesn't matter. Ta-da! I can't even remember, 8 7/8 inch disc. That's exactly the diameter of the Beaumont Machine Works one, so I just copied that. Alright, so here I have my sanding disc mounted on my lathe so that I can true it flat. I just roughed it out using this TIN coated crappy insert that's really, really dull. So I roughed it out, made it pretty flat doing that, but with a horrible surface finish. And then I'm going to throw in this nice shiny meant for aluminum insert to hopefully clean it up. And I got to get the feed rate right or else it's going to chatter like crazy. So I might have to play with that a few passes. I'm a little amazed that I can actually fit a 9-inch diameter piece on this lathe. It's called a 10 by 22, which means it can do 10-inch diameter. But I've never ever done anything bigger than 4 inches. So to be able to turn a 9-inch piece, I'm doing 560 RPM. I start at 150, too slow. 300, too slow. 560, it works fine. I could even go higher, but this is comfortable. So still a bit chattery, but much better than before. Almost to the point of being totally acceptable. Yeah, you can see it from this angle. But it's quite smooth. I mean, I'm super gluing a piece of sandpaper onto there, or spray adhesive. How flat does it need to be? I mean, it's pretty flat, it's just got a bad surface finish. Call it grip, for that matter. But I think it'll turn pretty smooth. How about a quick little update on Project Disc Sander? As you can see, I got it to work. Not perfectly, of course. Being fairly homemade, there's issues. Remember how I had the disc on my lathe and I faced it down? Well, the only way to make it perfectly smooth is either to make the disc and hub in one piece, or to actually take apart the motor and chuck up that shaft in the lathe so that the way it's side clamped is perfectly concentric all the time, blah blah blah. Basically it wobbles. But I got my VFD from Automation Direct. I finally got that to work. I plugged it in, or I wired it up exactly like it says here, read the manual, wired it, it just wouldn't work. And I don't know why, but these are the ground wires. They say these wires to INS, I-N-S. And I assume that means to ground. There's a grounding post right here. When I do that, it doesn't work. When I take them off, it works. So I don't know why, I don't care why. It works. So I just hit run. You can see it's going really slow right now. Faster, faster, faster. And there's quite a bit of vibration. I think at different frequencies, I don't know if it's the disc or the motor itself, but it shakes a lot. I haven't taken the disc off and just spun the motor, so I don't know if it's that. It could be a setting within the VFD that needs to be tweaked, very possible. But anyway, it does work. I don't have a rest thingy on it yet, so I'm just sort of playing with fire here. But being careful, I mean, it works. Lets me do what I need to do for now. And I got a big knife show coming up, and then after that I can deal with doing it properly. So what I'm using it for at the moment is, if you look really close here, you can see how my corner rounder right there went too deep and it left a burr on top. So I'm using it to basically cut that burr off. I got a piece of 600 grit sandpaper, spray adhesive to the front. Works great. So as you can see, it's sanding quite nicely. The lip is almost gone, so I'm going to keep sanding until it is gone. If I have any take-home notes, it's do not waste your time trying to build one of these unless you have more skill than I do, because I'm not too happy with that. I will be buying the one from Beaumont Machine Works. And because of the vibration, the motor does kind of walk around, so you're going to want to mount it to something firm. Maybe do the wiring a bit cleaner than this. Mount the VFD somewhere nice. Mount this to the bench somewhere nice. Interesting thing, I plugged the VFD into one of my circuits, and it's a GFI circuit, ground fault interrupter. And the second you plug it in, it trips the circuit. All my lights went off in the shop and everything. So that's why I'm over here by my lathe computer, where my new circuit breaker, where my new panel box is, because there's no GFI here. Hey guys, so it's been a few weeks since I've last filmed anything for my disc sander project, but I did end up getting a wheel from Beaumont Metalworks. Here's my old one. There's the new one. Theirs is 1/2 inch thick. I thought looking by pictures it was 1/4 inch, that's why I made mine 1/4, but theirs is 1/2. But as you can see in mine, the bumpiness, this like right here, it's just because my lathe is kind of loose. That did cause a bit of a problem while sanding, so this is kind of a bad idea. And this is $80 plus shipping. Not bad. I mean, it's totally worth it. This chunk of metal is probably $20 or $30 by itself, so it's totally worth it. I've got a bunch of aluminum bars here that I'm eventually going to turn into a rest right there, but that's later. Right now I'm just going to use it real quick as it is. I got a piece of 600 grit silicone carbide paper, and just got some 3M Super 77 spray adhesive. This is supposed to be the stuff, so I'm just going to spray it on, stick it on. This one I had a real hard time getting that piece of paper off. The first one that I took off was easy, but this one I can't get it off. So hopefully the new wheel doesn't have that problem. Alright, so I spritzed it on pretty lightly. I assume it doesn't need very much, because you want to actually be able to get it off. And the package said 10 seconds of dry time. And then I just take an old crappy pocket knife to scrape it off. Cool. Okay, what I am doing is I've got these little spacers for my knives, and they've just got a little bit of a burr on either side of the threaded area. So I'm simply going to hold them in the vise, or in my pliers here, and just tap them against the face to smooth them out. So much flatter than the old one. Holy cow. So this piece here that I just machined is the first part of the rest, the mount thingy that's going to bolt to the motor, so that I can have a flat surface to work from. So anyway, these are big countersunk holes where the bolts will go. 2 degrees crooked. Looks like more than that, but I guess that's all it is. Yeah, it looks quite crooked to me. But again, it probably doesn't matter, as long as everything's flat. So the theory is to put this back on. By the way, here's a close-up of the disc now that I have it off, I realized. Beaumont Metalworks, very happy with this thing. It's awesome. So the theory is to eventually have this plate mounted right there. I guess on the center line would be nice. With a slight gap away from the thing. But not so big that stuff will slip inside. And I just happen to have more of these laying around that I'm thinking will somehow go, wow, that's perfect. Okay, it's maybe 1/8 of an inch below center line, but that might work fine. 1/8 of an inch, I mean, you can make little spacers for that. Sweet!
Hey guys, Eric here. Just wanted to show you what I'm doing today. And I've been working with John to make that disc sander that he is showing you guys. And I'm just helping by making this little plate here. Kind of a rest. And I'm just milling out these pockets so the plate will be adjustable. And then these pockets right here so that the bolt lies flush. Focus.
Here we have it. Got the arms on, I got them drilled and tapped for M6. Last night Eric machined these screw location thingies. Yeah, these are still loose so that I can adjust, sort of bolt it all down. And they're slotted so that I can go closer or farther from the plate. So I've got 50 thousandths worth of shims right here, just what I happened to pick. It was super close and easy. So I just put them in there. And on second thought, each one's 25 thou. I think I'm going to go for 25 thou gap. Why not? So I just have to adjust things, get these 4 bolts in. So there we have it. Disc sander, plate, rest, whatever you call it. Relatively parallel or perpendicular to the face. I haven't measured like the exact angle difference between the two, but I certainly could. I'm just relying on the squareness of these things. And in here I put about 140 thou worth of washers just to get it a little bit higher. It's still just under center line. Maybe I'll put another washer on each side eventually. It doesn't matter that much. But, and then the last step that I'll probably do off video later is find a better place for this. Because somewhere that I can actually bolt it down. I notice now it's much heavier in the front, so it's actually tilting down. I didn't used to do that before. But yeah, somewhere that I can mount it permanently. This right here is next to my lathe CNC computer. Probably not a good place to get dust and all that stuff. Sweet! Seems to work. So I'll just take a piece of aluminum. Nothing, just that thing. Getting there, you can see the corners are polished. It's at a pretty low speed right now. One thing that I really wanted to try on the disc sander, and this is basically the whole reason that I built it, along with just the awesomeness of having it, is these are my blades, and the steel is RWL34, but it's a cold rolled steel. So it's flat, but it's got this pitting in it. So this pitting is what I want to get rid of. I want to sand these things smooth. They've currently been Scotch-Brighted, but it doesn't get rid of the pitting. It just sort of smooths it out. So yeah, the whole reason why I got it basically was to clean up these blades. These blades are hardened, so I don't know if they're going to be very easy to do or not. I don't know. Not bad after a quick 10 seconds of machining or sanding. Getting shiny. I'll just focus right on the tip here. Jeez. Okay, don't do that. I'm assuming the tip, the edge here got into the gap or something. Took a gouge out of the sandpaper. Yikes! Big difference, eh? I mean, it's not that I want them to be mirror shiny, although it's going to be awesome if they are. I just want that pitting gone. It doesn't look high-end. You know, it doesn't look like a stone wash, it just looks kind of bad. So once it's all shiny, then I'll be quite happy. So yeah, it's going to take a little bit of practice, but it's definitely getting there. Might take a slightly rougher sandpaper, like a 320 or something to start out with, and then a quick finish on 600. Maybe what I'll do is in the future I'll sand every one while the steel is soft, just to get rid of the pitting, and then maybe even with 320. And then when the blades are hard, I can go back with 600 and just make them awesome like this. It gets this wicked shine to it. It's currently using 320 grit sandpaper. When it uses 600, it's even shinier. And that's just 600. You know, not even a lot of time spent on it. But it's easy to make mistakes, I noticed. Like right here where my finger is, it's a big gouge. Because when you're machining, or when you're sanding, gotta watch out for the edge here. If you hold the blade like this, even the tiniest little degree, it'll put a gouge like that into it. So it's just a practice thing. But yeah, Eric's got a big pile of blades going here, sanding both sides. That is my disc sander project. Hope you liked it. Hope you found something useful, maybe. It's definitely a bigger project than I thought it would be going into it. Not that it's very complicated, but there's just a lot of little things to do and little things to buy, and it costs a lot more than I thought it would too. I'm probably looking at, geez, almost $400, if not a little bit more. Yeah, I forget exactly what I paid for everything, but I think the motor and VFD were about 3 something, and the wheel was just over 100 shipped. So the rest plate was free. I had it. But hey, now I have a disc sander. Yay! And a 1 horsepower motor if I ever need it for various projects or whatever. So yeah, thanks for watching. Cheers. Bye.